All right. So what are we talking about today, Brian? What are we looking at? I guess let's open up the screen share so we can show this slide.
Sure. So do you see the screen share?
One sec.
Yeah.
There. Scene's missing. Scene is missing a source. Hey, the scene's not missing a source anymore. So let's send it live. Yeah. All right, there it is. Understanding streaming aggregation methods. I couldn't read that if the screen share wasn't working.
Exactly. And it doesn't sound like a very exciting phrase here. But this is live, all right? And this is the sort of the capstone capability of a lot of the work, the re-engineering work we've been doing over the last year and a half. And a lot of our customers have gone through some updates last year in order to basically be able to take advantage of this final piece, right? And really the focus here is how do we increase the accuracy and reliability of alerting, right? While reducing the time to detect, right? So the holy grail of things, tell me quickly, tell me reliably, and don't tell me lies, right? Mm-hmm. So that's what we're trying to do here. And also along the way, I want to share with you what is in the process of rolling out right now as a little teaser, a little preview to build the excitement, to talk about or to show why you care about incident response, right? In our previous session, we talked a lot about the importance of having knowledge and information and context at that point of response, right? When you get that cliche page at whatever time in the morning, and you need to log on, you need the full power of New Relic to be brought to that moment, right? Mm-hmm. To help you understand what the hell is happening right now, right? And do I give a shit about it? Or do I give a care about it?
It's such a real thing that, like, when I say, hey, why is it that, when you work in communicating or product marketing or those kinds of roles, why do I really want that person to have been an ops engineer or a developer at some point? It's really because the reality of trying to get like an honest incident response is just, it's very hard to be real about that if you have not lived through it, Some product managers are up at night when something is not working. So, I think they get it, right? But just that sense of like, when you find that you're grepping logs, when you still don't know if anything's even down or not, like that's rough. That's a rough moment.
It is definitely rough. And for me, PM does not stand for page me. So I am not one of the people who are on the call getting paged as a PM. So
extremely real. Yeah.
So I can give sympathy, but not empathy.
Yeah. All right. So what are we looking at here? We're looking at alerts and AI by severity. What a beautiful.
So alert. This is the alerts and AI section. AI being applied intelligence, right? And one of the things I want to show about this screen here is a little bit of change to the left-hand navigation. This is because we are rolling out right now.
Brian, can we get like one step of Zoom?
Okay, one step. There you go. That makes perfect sense. How about on the right?
Hit me one more time. Hit me one more time.
Hey, man, babe. One more time like that. Boom.
Again. Okay, 18 plus 10. Yes, we got it. Everything's still visible.
Excellent.
Yeah.
So this is good because, I don't know, maybe people use their browser this big when they do this work. But so on the left-hand side, what you're seeing is the rollout of our new alert incident response workflow capabilities. Prior to this month, as we roll it out, a lot of these capabilities, these incident response capabilities, have been reserved for customers who have up-leveled to our incident response product. Right? Mm-hmm. But now we are making this available to everybody, right? So that when you land on New Relic, right? Hopefully the outbound message is richer, but then also once you land at New Relic to solve the problem, right? To see what this issue is, then we'll bring more data to it. And I want to give you a quick show about that. But I want to let people know that this navigation is changing and we are adding stuff. It's purely additive. Mm-hmm. We're not breaking any things you currently have, but we have, as a nod to where we're heading, moved the classic alerts things you've been working on down here to the bottom left.
Okay.
So when you log in and you go, oh, where's my stuff? Scroll down, you'll see it. It's still there. Nothing's changed. Nothing's been broken.
Like, I wanted to call this Twitch show, the change log instead of the nerd log.
Yes.
And someone said, well, what if we don't want to always talk about product updates? Like, well, first of all, I always want to talk about product updates. But here we have a real classic one. It's like, hey, folks, if you're used to this interface, something is changing now.
It is changing. Yeah. And, November is a little bit of a sketchy month for, anxiety. So I want to, allay that concern and say, don't worry, it's all still there. Nothing has changed. We're just giving you new options to explore as we roll out more capabilities.
We promise as you're trying to explore your Black Friday sale data that all your alerts are still there.
Yeah. And the great thing is now you can take advantage of this new and improved incident response feature as soon as we roll this out to your account without having to do any work. Yeah. And that's a key point here. I'm going to switch over tabs here because I don't trust here in this tab here. So we're introducing a new term, an issue. Before we said an incident was the roll-up of a thing. A roll-up of a bunch of events was an incident. Now we're saying that word is around, but it's really more about the atomic things. And we're rolling together these atomic things, whether they be violations or anomaly detection, automatic anomaly detection events, maybe other events, into this one issue. And then we'll augment that issue with other analyses and discoveries and context to help you really solve the problem, understand the problem at scale and solve it, right? Mm-hmm. So we have this one issues feed where before you would see the sort of index of incidents. Now you come into this issue feed, which is more interactive.
Okay.
So here you see all the issues that are in different states, active, closed, open, etc., and their priorities. And you'll see critical, high, medium, low. So we are in the process of expanding out the levels of priority that we support in detection and also in sort of this incident response cycle. So in this fictional scenario, I'm the dude who owns the portal, the web portal, whatever, right? Mm-hmm. So I can filter my stuff down. I can filter this view to only the things that I care about. And so look here, closed, that's good. Web response time greater than 300 milliseconds, etc. I can see there are 6 different incidents that have been combined together for this. I can see some components, some entities that are being this one, 4 different entities being affected. And I can see that this went from classic New Relic alerting, and this issue was communicated out using a Jira integration, a ServiceNow integration, and a Slack integration. So at a glance, it tells you kind of where we reached out to, right? And then let's take a little peek here. Again, the magic of tabs. Tab assume. So now when I click into this, you can see this is a lot richer, a lot more information than we used to show, or we still do in the legacy view of an incident. But now in this bigger view of an issue, we're bringing a lot more information right here to your face, right? To your crusty 2 a.m. face, right? Yeah. So you can see, again, 6 incidents. We picked the title based on the first thing that came out the door. But here are these incidents that were gathered together. And we can see, scrolling down, to get the context of what's happened here, we can say that, okay, there are 4 impacted entities. I can see a list of those entities, right? And I can drill down into the entity overview information for those. Or better yet, I can see a map. I think this is totally awesome here, right? I can see a map of this particular entity, web portal that I care about.
Yeah, this affected entity view is such a thing I wish I could have had in literally every incident I ever dealt with as an operations person.
Exactly. And the context is right here, right? Web portal. Show me more. Okay. Some golden signals to give you a view of the shape of the data coming in that you can drill down into. Where it's at. Oh, this is in staging, right? Where it runs at in 5 different hosts. So we have this context you can pivot into. And to go deeper, show me the entity preview. We slide out more details so you don't lose that place you're at in the application, and you can explore other activity, other golden signals, other relationships into a bigger map view. Again, just keep going down deeper. But okay, that's great. But what do you think is the problem? Well, here we have some information. We're trying to bring forward some other analyses or other event data that we know about to bring forward to you, right? So related deployments. Well, it's a good chance that somebody changed something and broke something. So this was 3 minutes after the issue started. Good chance good old Greg Parker here blew the effort.
Deployment thing has been out for a little while. It's really neat to see related deployments But this is also big, right? This is a thing from back in the day that
Yep.
really can always help. Is like some kind of marker to say, hey, code went out at this point.
Exactly. So yes, we've had it around for a while, and that's what I mean by bringing this power of New Relic to this moment.
Yeah.
So yeah, I have these entities. So what deployments affected those entities? Great, here they are. You can scan the list of them, right? We point the proximity of time to the last deployment, right? Error log, same thing. So here are all we can quickly pull to all the error logs in context in this period of time for those entities, for those specific instances, right? You have to go again, refine your logs. They're right there, and you can from there do further exploration. So that's the excitement of what's here now, what's being rolled out to everybody over this next few weeks, and why you care about having good incident detection, right?
Yeah.
It starts out with all good value, all cool whiz bang things depends on a strong foundation, a strong. At some point in time, you have to do the work, right? You have to put in the effort. We will do our best to identify abnormalities as we see them. But really, the more you hone this incident detection configurations to your environment and be specific about what's important to you at what levels, the more value you're going to get. Right?
Yeah, and I always say, in general policies, there's some sort of bright line ones to do early on about memory usage or what have you. But a lot of alert policies is going to be about something happened already in the past, like in the past week, and it was unexpected. And then you're like, okay, now in the future, I'd like to know about that right away. And we don't want an AI system to be like, oh, I hope it notifies me next time, right? We want to be able to say, okay, anytime that this metric starts climbing, go ahead and show me this. Or even, hey, anytime some number of events matches a pattern or some other cool stuff we can do with this.
Exactly. So when you're doing that retro, right, you run those queries, you go, oh, I don't know how we didn't have that particular signal being monitored, right? Going, right click on that little action menu, say create alert condition from here.
Yeah.
Right. It basically slides out and takes you to this screen.
Yeah.
Okay. Now, this particular example is from our demo environment. So hopefully, I have better demo god luck than Bassam did.
Well, hey, here's hoping anyway.
Exactly. So here is a situation where we're doing a count of logins, right? Where login does not equal success. So, sadly, there's a lot of failed logins on this particular demo. Yeah. But the good part about that is the data is consistently coming in. There's consistently information coming in, right?
Yeah. The other really nice thing about that is this, again, is like no metric is being generated here to begin with, right?
Yeah.
No agent is reporting up like failure rate of logins, right? We're
That's
just
true.
able to go through and look at transactions and see, show me how often it happens that they're not marked as successful.
Exactly. You didn't have to pre-instrument, because this is off of events, you did not have to pre-instrument your metrics, right? Which are efficient, but take some forethought typically.
And this is the thing I think that drives, especially like DevOps people, a little nuts, is to say, well, we had this incident, it's a problem, and then to say, to actually know that I have this in the future, I have to like go and edit some code or edit some settings on those servers. It's like, oh boy, do I have to do that, and so on and so forth. Hopefully we're in this position where we can say, oh no, we're already getting this into New Relic. We just need to alert off of it now.
Exactly. Capture rich event data, and you have much more flexibility.
Mm-hmm.
And we have the scale. So, but what we're going to talk about here today is how do I take this signal, understanding my signal and the shape of my signal, right? Again, is it events? Is it sporadic? Is it metric time series data? Is it consistent in that regard? So with some understanding of your signal, you can really now come and tune down some of these advanced signal settings in order to, again, get the quickest response time, if that's your primary concern, or to ensure that you get the maximum amount of accuracy, right? Depending on the complexity of the signals coming into your environment.
Mm-hmm.
We'll talk about that in a minute. So when you come to the screen, you'll see this little pop-up here. Again, this is additive. We didn't break anything or take anything away. We created a name for a thing that already exists, because now we add peers to it, other things. We have to name the child. Like if you only have one kid, you can say, hey, kid, come here. But once you have multiple kids, it becomes more challenging. You have to come up with names. So here it just tells you, hey, we've replaced the evaluation offset parameter that you're used to. We've introduced new methods. And we recommend moving to this new default, this thing we call event flow, and you're like, I don't know, should I just use this event flow thing you're talking about? And you can read about it a little bit over here on the side, or go read the docs. But humans are lazy, especially me.
Okay, all right.
So I may say, forget it. I'm not here for this right now. I'm here for something else. So I'm going to say match current settings and move on.
Yeah.
Right? And match current settings says, oh, I'm to use this thing called cadence, which I don't know what that is, but okay, you said it's the same thing because we just gave that a name. That used to just be called how it works.
Yeah.
So now it's called cadence. And instead of evaluation offset, we call it delay. But we figure out the mapping. So here, you said, great, move forward. I got other things to do. Don't disturb me right now. I'm in my busy season. But really, what we determined is we can't find a good use case whereby event flow method or the event timer method is better than how we've been doing it.
Okay.
So we highly recommend that you choose the default, and or if there are some cases which I'm about to talk about where that's not the ideal, then choose event timer.
Yeah, this is this thing that one gets into, especially like after the fact. It's like, hey, this generated an alert or it didn't, right?
Yeah.
Like, and from way back in the day of doing tech support for New Relic, I remember this coming up. It's like, hey, if the error rate spiked to 100%, but it was just for 1 second, right?
Yeah.
Or hey, the error rate went to 30%, which was never over the threshold, but it sort of kept popping up to that level, every 1 minute out of every 10 for hours and hours. So it was a serious problem, but it just fell below these thresholds.
Yeah.
And there's a dozen ways to handle that, including, thinking about your alert fatigue and thinking about how insensitive you're making your alerting. But occasionally you just do get to the point where you're like, hey, I need really detailed settings here of how these time bins are designated. And so this is going to help you control that.
Exactly. And so I just wanted to show you here in the product where these settings were and the experience you encounter when you first come to these pages now after we've released this feature, so that you know that you can just click, give me the same old, I'm moving on, I'm busy. Or you can take the opportunity to improve it and choose either event flow or event timer. But now let me talk about what these even mean, right? We will be releasing some capabilities that will look at your signal and say, oh, your signal is a shape A versus shape B versus shape C. Therefore, this is the ideal model. And you can override me if you want, but really, we've already sort of made some assessments. First step was to release the controls. You have the ability to make the change, and then the second step will be making it easier and automated. So it's good to understand a little bit about how our alerting platform works.
Okay.
In the sense that it is entirely a streaming data platform.
Okay.
Right? This is different than some other vendors who will continually query the at-rest data.
Right. Right. Okay. Yeah.
And so it depends on how far you look back, whatever. The data got there, it's eventually there, right?
Mm-hmm.
If my data is always coming in an hour late, but I look at that data querying, in 6 hours and look back at time, I don't know the data was an hour late. It's there. The timestamps say it was there. Well, it all looks good, right? There's an eventual reality that exists.
Yeah.
But when you're dealing with streaming, time is important. Right? The temporal aspect of that data flowing through the system is relevant.
Okay. Yeah.
So in the current system, we'll talk about this more too, but it's using the clock to move the system forward, right? So it's a synchronous thing at the end of an asynchronous distributed data pipeline. So when you have asynchronous running into synchronous, that's usually a problematic pattern, right?
Yeah.
So we'll talk about that. But here to know that data flows in, from your agent, it flows into our ingest pipeline. This is all streaming as well, and it gets put into two places. It gets dumped over into our NRDB storage platform. That's great, massive ad hoc query capabilities. And then it gets streamed into our streaming aggregation pipeline and our streaming alerts pipeline, right? And that's what we're going to talk about. So let me give another little quick refresher here about what that platform looks like. I'm not going to go through all this because this is more detail than necessary. Other than to say on the left-hand side of the screen, we have the streaming aggregation portion of it. Right? Data comes in huge volumes. Say you're monitoring 1,000 different mobile devices, right? Every 30 seconds, they're giving you more metrics coming in, right? But really, what we want to look at is if the average on a response time for all those is high, higher than expected. So I need to get 1,000 data points brought together and aligned to the right window buckets, right? So that I can then run my aggregation function or whatever other analytical calculation I have on that 1,000 data points in that 30 seconds. Or if I want to say 2,000 data points over 1 minute, so I can produce one data point that the alert system will evaluate over a frame of time. Right?
Okay.
If that's over 5 minutes, if that's consistently over the threshold for 5 minutes, tell me, right? Open an incident up, create an issue, tell me about it, etc. Right? So that's these two parts of the equation. And what we're going to focus on first is this section here about how do I know, me as the streaming aggregation function.
Mm-hmm.
Once you tell me my time window is 30 seconds, or my time window that I want to collect data from is a minute, how do I know that I have all of the data here in front of me for that 1 minute before I run my one-time aggregation query and submit that data downstream? I don't know how many data points to expect. Now there's 1,000 account, 1,000 mobile agents. Maybe in next month there's 1,500. I don't know.
Yeah, this is like a classic request from any kind of observability tool. It's like, can't you tell me when we're not reporting data? And if it's a single VM, sure, right? But if it's in the real world, no, right? We don't know that we're missing reporting from a single host.
Yeah, except for I don't know, that person didn't come to the party anymore. I don't know, maybe they're not coming.
They're not running Foursquare.com anymore.
So this historically, we have used a method. So let's call that the streaming aggregation method. How do we know when data streams in and we're aggregating it together? What is the method or the heuristics we're using to determine when we have it all, right? And if we have simple signals, we can crank that thing down because we know there's not much need for accommodation of reality in the universe, right? You have a lot of signals coming together from a large cluster or a distributed environment, multiple clouds, for example, then you may need to accommodate the reality of how that data is coming into us. Latency on different network environments or clock skew or various things come into play, right?
Mm-hmm.
So this previous method, which we now created a new name for, the cadence method, again, always based on the clock. And what we've done is we've changed that to introduce two new methods that are based off of the event activity of the data flowing in.
Okay.
So the system sits there. It goes, I got this time window here. That's for 1 o'clock to 1 minute, 1 o'clock and 1 minute, 1:01, right? And I know there's no data, right? I know it's not 1:05, it's not 1:30, it's not 2 o'clock. There's no data. Okay, I just sit there and I wait for data coming. Goes, oh hey, I'm finally here. Look at my timestamp. I belong at 1 minute and 30 seconds.
Mm-hmm.
Oh great. Now I'll put that data point into that window. And now we can start to do things. Now the machinery wakes back up again, right? So this is great for if you have a data disruption or we have a problem, right?
Yeah.
So it used to be if we had a problem and no data was there, we say, 1:01 has passed. You told me to wait 3 minutes. 3 minutes has passed. That window is moved forward.
Oh, I see. So not event-based, like looking for an event marker on the data, but actually just saying the event of data coming into that.
Yeah, exactly. Yeah, like a river flowing in, and you have one of those old water wheelie thingies,
Yeah.
Turbine, I guess you'd probably call it. The turbine needs the water to flow. If the water stops, it doesn't keep spinning magically.
Yeah.
I guess not. What do I know?
Yeah, like the idea is like, hey, if you're sorting mail, right, like you're going to reevaluate if there's a big stack of mail when you get a new letter that you put into the pigeonhole, right?
Exactly.
So look, now that I have this, things look bad. Okay, right? That's the point that you want to reevaluate. That's cool.
Yeah. So now the whole system, end to end, from you collecting data to publishing it to coming through us, streaming through, to you being alerted, is all asynchronous, event driven. Right? That's the big thing. So that should reduce latency, improve accuracy, and reduce false alerts. Typically, we complain about false positives because that could wake you up, or give you too much anxiety. But also, false negatives are also a concern, right?
Yeah, the right combination of false negatives can be super bad.
So this being a nerdy talk, sort of the more you know session here, right? Like, what does your data look like? If you visualize it streaming through the universe, what does it look like?
Mm-hmm.
Do you have a metrics agent, ours, some other open telemetry agent, open source, whatever it may be, right? That every flush interval, every 30 seconds, every minute is emitting new data to us, right? It comes consistently, it comes frequently, right? That's your most common metrics time series monitoring situation, right?
Mm-hmm.
How infrequently is the question, but typically it's consistent. And that's great. That's a simple flow. It's like water, flows through the system. And you can say, I know I have this data of this window when the data for the next time window is coming in, right?
Mm-hmm.
It's pretty consistent, inline data, right? So that's easy. If you have one signal for one entity and one CPU, one metric, couldn't be easier. Next data point comes in, it pushes that data point down the stream, it gets aggregated and alerted. High accuracy, very low time to detect.
Mm-hmm.
I think we currently do 5 second minimum. So at most there'll be a 5 second latency on that data. We'll talk about that here. But sometimes signals are inconsistent, like that demo we showed with the NURCL condition form.
Mm-hmm.
A count of errors. Hopefully your errors are not consistent and frequent. That's a bigger problem. So you may go hours without having any other error event data coming through. So again, do you want to wait for that other event 3 hours later to push your thing through the system? No. So if that's the case, we need to treat it differently. And the worst case of all worst cases is getting data from a cloud provider using a polling mechanism, right? Calling an API to get batches of data. The data points are frequent and consistent, but the temporal aspect of it, the time which you get them, I got a batch, process it. Mm-hmm. Wait 5 minutes, maybe 30 minutes, maybe, I don't know. Sometime you're going to get another batch and it comes in. So, what's the algorithm we're using to make sure that data is processed in a way that's not kind of awkward, right?
Yeah.
So again, it's good to know your data. And right now, that's where you're going to be when you're choosing these options, if the default isn't working for you, before we automate that even more for you, right? Yeah. Again, driving home the point, when you rely on a clock, you'd be like this guy who got to the train 5 minutes too late.
Yeah.
You can fill in your own sort of swear word what he's saying there, but it's not good. You see the clock above it, train left. He didn't care that your asynchronous bus got there too late,
Yeah. And then you have this balance down this last bullet point that sticks to me is like, hey, if you really want to be fully accurate, then you're going to have to increase latency, right?
Yeah.
If you give me half an hour to alert you about an outage, then no problem. I'll be certain that it's actually happening.
Yeah.
But that's also a complaint, right? That's
but what's the point? It's like, you're missing the point of the objective here. Exactly. So that's the key point.
I've seen custom queries on dashboards where someone has set always run this for the last 10 seconds. And I'm like, well, that's not good because you don't have data consistency in the last 10 seconds.
In the last 10 clock seconds, you may not get nothing.
Yeah. So some people, when they get the time window really close, when they're like, oh, I'll set this time window to the last 20 seconds. They're like, I always see throughput dropping off a cliff right now, right? But then when I refresh, it's not happening. It's happening.
If you know your data and you've instrumented it, rock on. If you know that's the case, but So jumping forward a little bit, instead of there being this tyrannical train leaving, every bottom of the minute, I think of it now maybe as a metaphor of these robot cars. Waymo in San Francisco, the robot cars there, but it's assigned to you. You've reserved it. It's like, okay, I know my plane was an hour late, but I still have an arrival time of 1 o'clock, in 30 seconds. So wait for me till I get there.
Yeah.
Yeah. And then when I get there, the question is, how many are in your party? Oh, you don't know. It could be a bunch. Who knows? Okay. How do I know when to go now? Right. So I've eliminated now the pain of false positives or inaccurate alerting because those windows go too early or go empty. Right. So now the question is, do I make sure I have all the data here? Again, so the event flow is the primary new default mechanism, replacing the cadence method for all intents and purposes. And it says, okay, great. The only knowledge I know about time is the timestamp that the data point shows me. I don't have my own clock. I don't have my own watch. I can't afford that. People have to tell me the time.
Yeah.
Right? So a data point shows up and says, "I'm here for 1 minute and 30 seconds." Great. You go in the 1 o'clock to 1 minute button, bucket, the window.
Yeah.
Another data point shows up and goes, "Hey, I'm here for 1:02." Oh, good. A minute must have passed.
Okay.
Yeah. I'm here for 1 minute 3. Good. 2 minutes have passed. So I could say, if I am only watching for one signal, set that basic timer down to pretty much equivalent to 0. So as soon as the next data point shows up with any time that doesn't map to that 1 minute window, go. I have all the data. If I say, well, I have 1,000 mobile devices, let's give it, by time a data point shows up for 2 minutes from now, good chance I've probably received all my data for the first window of time, prior to 2 minutes. So again, when it shows up, the data point shows up and says, "I'm here for 1 minute and 1 o'clock and 3 minutes." It goes, "Oh, 2 minutes has passed." So I should be good to ship that data point now, that aggregated data point down to be alerted.
Got it. Yeah.
And so,
I'm sorry, go ahead.
Yeah, I would say, so that's great when there's consistent flow and you don't have a large spread in between data. If you have a consistent flow every hour, I don't want to wait. I'm not going to wait an hour until the next data point comes to push me down, right?
Yeah.
In a loving way. It pushes them down in a loving way.
Yeah.
So you say, well, I want fastest time to detect when my S3 bucket alert, tells me that it has whatever new volume storage every hour. Great. Mm-hmm. So I go, hey, I'm only getting one data point. I don't need to wait at all. I'll set an event timer. An event timer is once I get the data point that aligns to that one window. This is the 2 o'clock to 2:01 window.
Yeah.
I'm not getting data till another 3 o'clock time, but I don't care if that data point is 2 hours late getting there. That system stays in place. So it's still event-based. But when it drops, I start a little, kitchen timer, right? A little egg timer. The one that makes that sound, Yeah. And if that timer expires before I receive another data point that maps to that same window, then I'm good. Go.
Yeah, then I'll just call an alert or lack thereof.
Yeah, I don't need to wait for any other data to show up before I run the average function or the max function. I'll just pass it along. I just say, great, run it, max that one data point. Is that one data point? Send it downstream to be evaluated. If you have a condition that says, if my S3 storage goes above 2 terabytes, then tell me, right? Yeah. So as soon as that one data point hits, it'll be immediately evaluated. It'll be immediately notified, within seconds. Because you can say, set the event timer to 0. Great. I only want one data point. Now, if I have 100 servers that report once an hour, I may go, okay, comes in. I'm going to give a 5-minute window of time because I'm going to there may be a little bit jitter when those things emit the data. And I'm going to set a 5-minute timer because that way I know I'll have at most 5 minutes of latency and I should probably get all my data in line. I don't need to wait for another hour. It's the good sort of a hybrid blend of event activity for reliability and also a timer because the flow is unreliable.
Yeah.
And that's what we've introduced. These two capabilities. So in general, I say go with the default unless the default ain't working for you.
Yeah.
Yeah. And then it's like, okay, look at your data. It goes, oh yeah, my data is pretty sporadic, unreliable. And then understand a little more and put a timer in place to make sure the machine keeps moving forward.
Yeah, and you actually do I have people who have, they've engineered custom metrics or custom events, and they really do. They just want an alert if something happens even once.
Yeah.
Right?
Yeah.
It's, whatever.
Who knows when it will happen?
Mm-hmm.
Yeah. So it's like event flow is the primary, event timer is the oddball case, but there's a lot of oddball cases, right?
Yeah.
And then I would like to say, hey, using either of those event-based methods, you will no longer receive false alerts because we're asynchronous and we just chill out and wait. But like you mentioned, how do I know if a thing no longer exists? Right? Well, you say, well, I'm not receiving a signal, any telemetry, any data from that thing anymore.
Yeah.
Is it dead? I don't know. Maybe it's just a little bit late. I don't know.
Yeah.
It didn't tell me it's dead. All I can do is assume. Okay, well, wait 5 minutes. If you don't hear anything for 5 minutes, assume it's dead.
Yeah.
Wait 10 minutes.
And these are things you set up ahead of time, right? So
yes,
you hopefully have some reason to set a window a certain way, right?
Yes.
You're like, hey, this thing is right on this trunk line. It's always going to report, and so I do want to know right away, right?
Yeah. Now, but we're back to the tyranny of the clock. Right?
Yeah.
The only way to know is every time I receive a data point, I go start the timer. Oh, 10 minutes went by. Alert you.
Yeah.
We think it's dead. If it comes back, I'll tell you, but we think it's dead. So my only point here is the other two new methods, the event-based methods, will greatly reduce false alerting. Right?
Yeah.
Be careful how you set this setting. Right? Like you said, 10 seconds of data. You don't show me in 10 seconds. I'm like, there's a lot can happen that adjusts 10 seconds.
Yeah.
So the more aggressive you are at this, the greater chance some time-oriented thing, as that piece of data flows through the universe, may happen that will cause that to be sensitive. So be honest or conservative about how you set that signal loss timer.
Be a little bit thoughtful about, of course, this is the point, right? Like, it's an easy dashboard to adjust, right?
Yeah.
If you're getting alerts, you should have access to this dashboard. So, if you're getting alert fatigue, right? Like, audit this and say, hey, I need to change this threshold.
Yeah. And there are times where we may identify that we have some lags in some of our Kafka queues. Right. It's no surprise we're a huge Kafka user. So this is all flow of Kafka queues. Right. And when we see that, we sort of stop the system trying to suppress data. Right. But, it could be like your timer has been going for 9 minutes and 35 seconds. And it took us 2 minutes to realize there was a queue problem. Right. And so you may still get alerted for this timer because, it's a race as far as when we can identify an issue we have versus when your timer is about to go off. Right. So you can still get some false alerts with loss of signal if we're having problems, but we try to identify those issues quickly and do some noise suppression when that happens. And that's really the big thing that I want to talk about today. Right. And just looking at, repeating, when you have a frequent and consistent signal, you can use now a more advanced set of controls to really tune down that, detector, right? In order to minimize noise, but also maximize your time to detect efficiency. And that's it.
Yeah, I really like this. I really like the fact that this can also support like open source data sources.
Yes.
Right. And so by letting that logic exist right on the ingestion side, do we still use the term ingestion side?
Yep.
Right. It lets us make some pretty intelligent decisions about what kind of decisions we're making about identifying that data.
Yeah.
But sorry, go ahead.
One quick thing too, since we talked last, is looking at open source data and open telemetry data, right? We have the new sort of entity synthesis capabilities now, so we can identify, that's open source type A or B, and we can create an entity for it in our entity-centric platform, right? And now for all NRQL conditions, if the resultant signal, if you use a query, facet, max CPU, facet by host name, right? Well, then you'll get CPU, one signal, right, will apply to one entity. And when that's the case, we'll pass that entity GUID, down into alerts, and then we'll make sure that any violations that are created will be part of the whole entity ecosystem. Right? So we'll update the entity-based activity view. It will affect the entity health status. Right? We'll bring in tags from the entity tags itself and enrich the violation. So now, without having to do any additional work, all NERCL conditions are now also part of the entity-centric platform.
Got it.
Yeah,
that's neat. Brian, this was a cool presentation. This is some real. Did you do this for Data Nerd Days as well? This is a good one.
Yeah, that's why my template is still.
Hey, no worries. This is like. I do just want to mention before we close the broadcast, and Yupeng, thank you so much for coming out. I know that you have to drop, so we will go ahead and push you to next week unless you have time now. But that's totally fine. We can push you to next week's broadcast. Yes, thank you so much. Feel free to drop. I do just want to mention thank you so much to everybody who came out for Data Nerd Days. It really does remind me of it. Brian, where do you want to be found?
At the bar. Is that a legit?
You coming to reInvent? You coming to reInvent this year? That's my question.
I am not. ReInvents are a little chaotic for me.
Yeah, it's a little much, isn't it? I'm doing it this year.
But I guess it's in person?
It's in person.
There you go. So that's a start.
Hey, my kids are getting vaccinated, so I feel more chill about it. The first work travel I had to do, I had to come back and like be away from my kids until my COVID test came back. I didn't love that.
In your bubble. Exactly.
Yeah. So thank you so much. I encourage people to come and check this out. If you're just getting started, hop on and take a look at some of the amazing ways that we can add some intelligence to your alerting. But yeah, otherwise, folks, check the show notes for documentation of this stuff and the Data Nerd Days recordings if you want to see an even more in-depth presentation. But yeah, thank you so much, Brian. I'm going to close the broadcast. Oh, cheers. Check out the Nerd Blog every Thursday, folks. We're on LinkedIn. We're on, you're watching us there. So, hopefully, right? But thank you so much, everybody. We're going to close it up and have a good one.